Hello, and today we're going to be going over lesson 2, and we're going to be going over graphs of proportional relationships. So, yesterday we did some stuff that should have been a little bit of a refresher from 7th grade, and we're just going to repeat some of that here. So, once again, our constant would be represented with our y over x. And then our equation for a constant of proportionality would then be our y equals kx. So those two things we should have went over yesterday, and so just a refresher here. So right here is an unknown situation. So this line here represents something, but we don't know what. So we need to write an equation for this graph. Well, in order to do that, we need to find its constant, okay? So we're going to use the points it gave us. So let's go ahead and find those coordinates. So this point here, its x value would be 8, and its y value would be 14. Alright, now up here, this other point, its x value is 16, and its y value is 28. Alright, so x and y, always labeling so that I know where I'm putting them. Okay, so I need to find my constant. Well, it's my y over x. I'm going to use this point just because the numbers are smaller, okay? But you can use either point. So my constant is y over x, and so I'm going to put my y is 14 over 8. Alright, now we can reduce this, okay? So let's reduce it by dividing both of these numbers by 2. If we do that, we end up with 7 over 4. So we can't reduce that anymore because we can't divide 7 by anything besides itself and 1. So our constant for this line is 7 over 4. So let's go ahead and write this equation for the graph, and we're going to use our constant of proportionality. So the equation for this line would be y equals, I'm going to plug in 7 over 4 for my k value, and then x. So right there would be the equation for this line. Alright, so now it says we're going to sketch a new graph of this relationship. So we're going to use this graph here to now sketch that line, okay? So the first thing we need to notice is we need to see what these represent, okay? So these are, each unit is increasing by 35 on the y-axis, and it's increasing by 20 on the x. So make sure you always look to see what the graph, how the graph is increasing, because it's not always by 1. Alright, so we need to figure out how we're going to plot points on here, because over here our numbers are a lot smaller. So let's go ahead and create a table of our x and y. Alright, so here are our x values and here are our y. Let's go ahead and start with something we knew. So this is the same relationship, it's just different numbers. So our x value is 8, and we ended up with 14. Now how did we end up with 14? Well, we took 8 and multiplied that by our constant of proportionality to get our y. So our constant of proportionality, or our constant times our x, constant times our x equals our y. So that gave us 14. Alright, now you can have a calculator to help you with this, okay? So let's go ahead and do this again. So let's use 20. So that is our on our x-axis, so it's our x value. So we're going to take 20, multiply that by 7 over 4. We would then get 140 over 4. Alright, now you can either reduce that or divide, and we would get 35 as our answer. So our y value would be 35. So our x is 20 and our y is 35. So we can now plot that point right there. Alright, so if you need to rewind to watch me go over that again, go ahead. If not, we're going to do another point, okay? So I'm going to take my x value, let's go with 40. I'm going to plug this into this equation up here. So I'm just taking my x, which is 40, times my constant. So 40 times my constant. And if I do that math, I would end up with 70. You can go ahead and use your calculator to help you there, okay? Alright, so now my y is 70. So let's go ahead and graph this. At 40, I'm at 70. There we go. Not too bad. So we can continue, but let's not. So let's start at the 0. We're starting at the origin, and we're going to draw our line through our points. That is not the best line, but there we go. Okay, so there's that. And so once again, we are taking same constant, and we're just plugging our x and y values in, or our x values in, and multiplying by our constant to get our y. Alright, so in class we'd be doing a card sort, so instead I'm just going to go over a few examples with you. So we're going to have a few different lines, and we're going to find the we're going to write equations for those lines. So we're going to use the format of y equals our kx, and so we need to find our constant, and we'll plug it in and we'll call it good. So our constant is our y over x. So I need to find my y and x value for this point that they gave us here. So my y is 6. And then my x is 24. So I'm going to plug these in here, and I will have, so my x and my y, I would have 6 over 24. Alright, if you have your calculator near you, I'd grab that or use the one on your Chromebook. 6 divided by 24 gives you 0.25. So I'm going to rewrite this as y equals 0.25x. And that is my proportional relationship for this line. Okay? Now let's go ahead and do this one here. So, right here, I need to find my k, which is y over x. And so my y value for this point is 6, and my x value is 2. Sorry, I was looking at the wrong spot. So we're going to plug that in, and we have 6 over 2. You simplify that and you get 3. So my equation would be y equals 3x. Alright. Let's go ahead and let's do this example. Alright, so we have some bigger numbers here, okay? So once again, my k is y over x. So I'm going to find my x and y. So my x value here is 300. My y value is 400. So I'm going to have 400 over 300. Well, that one's not too, it's big numbers, but that's not too hard to simplify, okay? So we can just divide both of them by 100, and we end up with 4 over 3. So we can just write y equals 4 over 3x. Alright, so there's that. Let's go over one more example. We have some decimals down here, so let's do this one. So once again, my k equals y over x. Let's find my coordinates. My x value is 0.2. My y value is 0.5. Alright, so I'm going to write my 0.5 over 0.2. Alright, and if we were to multiply both of those by 10 to get whole numbers, this ratio is 5 over 2. So we can plug that in and have y equals 5 over 2 times x. Alright, so there's that. Now we're going to go back to our book. Alright, so on to the last activity here. So we have 2 large water tanks filling with water. Tank A is not filled at a constant rate, so you can kind of see how that curves there. So let's go ahead and call that A. And then tank B is going to be filled at a constant rate, but we need to graph that line. And so it's at a rate of half a liter per minute. Alright, so the relationship between its volume of water and time can be described through this equation. So it's pretty similar to our y equals kx, where 1/2 is our constant, and we're just using volume for y and our time for x. Okay, so very basically our other formula, just different letters. Okay. Alright, now, of course, our questions are on the next page. So it says, sketch and label the graph of the relationship between the volume of water and time for tank B. Alright, so let's go ahead and do that. Okay, so we know that it is a rate of half a liter per minute. So at 1 minute, we know that it has gone half a liter. We can go ahead and plot our point there. And so at 2 minutes, we know that it would be at a full liter because it's just doubling our time there. So we can go ahead and draw our line starting at the origin through our points. Maybe. Okay, I tried. Okay, so there is our line there. I'll call that line V. Okay, now what we're going to do is the same thing down here. So, in order to do this, we need to draw a table, because first off, we need to look and see that our numbers have changed on the axes, okay? So, V equals 1/2 T, and so we're going to label our time, and then our volume, and we're going to plug in our time, so we'll use the numbers 20, 40, 60, and 80. And we need to find our volume. So we're going to plug in our T values, multiply them by half to get our V. So V equals 1/2 times 20, so V would then equal 10. So this would be 10 there. We'll continue that pattern. So V equals 1/2 times 40, so V then equals 20. So you can continue to write that equation out and fill it in, or you can just see that each of these numbers are taking our original and dividing it by 2. So then this would be 30, this would be 40. You can even add one more at 100. Half of 100 is 50. So now we at least have that information, okay? Okay, so up here, it says, answer the following questions. Oh, let's graph this. I apologize. So at a volume of 10, we're at 20 minutes. At a volume of 20, we are at 40. And we are continuing. So at 60, we're at 30. And at 80, we're at 40. And then at the very end here, we're at 50. I need to get a different straight edge. Okay, so here's the little dog coupon. Okay, so I'm going to start at the origin and draw my line. So there we go. So now we have that on both graphs, okay? So now over here, it says we might have to use both graphs, but we need to figure out after 30 seconds which tank has the most water. So if I look over here, 30 seconds, this is going by 20 minutes, so I'm going to use this one because it is shorter. So at 30 seconds, which is half of a minute, so here's 1 minute, so we need to do half that distance, which would be right about here. Let's see which one has more water. So if I'm going up, this has about 0.3-ish, and then this one, tank A, has close to 0.6. So tank A has the most water. Now, at approximately what time do both tanks have around the same amount? Well, up here our lines don't cross, so we can't use that. Now down here, it's hard to tell, but somewhere in here our lines cross. And so it looks like it's right in between 60 and 70 minutes there. So let's go look up here. So we can say around 65-ish minutes, because they cross. It's hard to tell exactly where, but it's somewhere in between these times. So whatever estimate you have there works. Alright, now here it says at approximately what time do both tanks contain 1 liter of water? So for 1 liter, let's see, A and then B. So let's see what time for both of those for 1 liter. So when it comes to 1 liter, we're going to use our smaller graph. So right here, here's 1 liter. Dun, 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 dun. At 1 liter, tank A is at 1 minute. So it takes tank A about 1 minute to get there. Alright, so for here, let's look to see when it crosses B. It's supposed to cross right here, but my line wasn't great. So that would be at 2 minutes. So it takes 2 minutes for tank B. Now what about 20 liters? So let's find tank A and then tank B. Alright, so we're going to use our bigger graph down here. So when we get to 20 liters, it looks like it takes our tank A, it looks like it's slightly past 35-ish, so we could go with 38 minutes. 38 minutes. You can estimate, you could say 35. Somewhere in between 30 and 40, but closer to 40. Because if we look here, here's 40, and that's 30, so slightly past that there. Okay, so let's look for B. Well, it looks like it intersects right there on the dot at 40 minutes. So, we're over here, we're going to write 40 minutes. Alright, and that is that.